Hi everyone, in this video, I am going to discuss about subgraphs. So this is the formal definition of a subgraph. So a subgraph of a graph G consisting of a set of vertices and a set of edges is a graph consisting of a set of vertices W and a set of edges F, wherein the W is a subset of V and F is a subset of E. A subgraph H of G is a proper subgraph of G if H is not equal to G. So again, this seems a bit difficult, but let me simplify it for you. So we have here an example of a graph, and this graph consists of vertices V and a set of edges E. So the set of vertices V consists of A, B, C until F, while the edge E contains all of the edges that you can find here. For example, A to F, A to E, A to G, and then A to C, and so on and so forth. Now, we said that a subgraph contains a set of vertices W and a set of edges F. So if we have this subgraph highlighted in red, so this subgraph contains this vertices W, A, B, F, and then E. And it also contains these edges A to F, A to E, B to F, B to E. So I did not rewrite FA, EA, or FB and EB anymore because this is an undirected graph anyway, and the order does not matter. Okay, just a segue. Now, we can see that all of the vertices that are included in W are also included in the set of vertices V, in which these are vertices of the original graph. And the set of vertices F of the subgraph, which is highlighted in red, the edges here are also included in the edges of the original na graph. Okay, so we can see that, or we can then say that W is a subset of V and F is a subset of E. And as you can see, it has been stated here. Okay, so we can then say that this subgraph that is highlighted in red is indeed a subgraph of the graph G. Now, we can also say that it is a proper subgraph since it is said here that H should not be equal to G. And if we look at the equality of V and W and E and F here, we can see that they are not equal. So we can then say that H is not equal to G and therefore a proper na subgraph. Okay, now let's look at this example again. Still, we have this original graph consisting of vertices V from A to G, as well as all of the edges. Now, we have this another graph. Okay, and we can see that the W here, the W is composed of the vertices A, B, E, F, and then H. And the F, on the other hand, which is composed of all the edges of this graph, it has AF, AE, BF, BE, and an additional FH, and then EH. But if we look at the original na graph, this H is actually not part of the original graph. Okay, and we can also see it here. The vertices of the original graph are only A, B until G, but not H. And then we can also see that the FH and the EH are not part of the edges of the original graph. So since that W is not a subset of V and F is not a subset of A, so of E, I mean, so we can then say that this is not a subgraph. Now, let us have this example. Going back to the original graph again. Okay, and again, these are all the set of vertices and the set of all the edges. And assuming that we took the whole graph as a subgraph, So the W will then be equal to V, and F will now be also equal to E. So there is an equality in these sets. And as you can see, the H is equal to G. So we can then say that it is not a proper na subset. So this is still a subset, but not a proper na subset. Okay.